Now let's begin working with the formal syntax of epistemic logic. The beginning here is that we need to start with a set P of propositional letters and also a set I of agents, and then we can define the basic language EL. We're going to work with different languages, so it will be useful to have different names. So EL refers to epistemic logic, and here's how we can define it. So given any propositional letter, that propositional letter by itself is a formula. So given P in capital P, P is a formula. So again, we're using the term formula to refer to the sort of legal expressions in our language. And so then we say if phi is a formula, and we're also going to say and I belongs to the set of agents, then the following are also formulas. So this is the same kind of inductive definition that we've used for propositional logic and for predicate logic previously. Now we're using it for epistemic logic. And part of this will be very familiar. We're going to say, well, the negation of phi is also a formula. The formula, actually I need a couple of formulas here. Let's say, and psi is a formula. So I also want to say that the conjunction phi and psi is a formula. Phi or psi is a formula. So much, so far so good. I mean, this is just exactly what we did in propositional logic. As it turns out, I'll come back to this in a moment, we're not going to formally introduce the implies connective or the equivalent connective into our language, although we can always use those because we know how to propositionally define those in terms of negation and or. The new connectives then are these. Box or the knows predicate with agent I can be attached to phi, or another predicate, we'll talk about this one in a moment, a diamond or a sort of rotated square with agent I can be applied to phi. So again, you can kind of imagine how you can build up more and more complex formulas using these connectives. And really the only thing that's new here are the two new connectives, the knows formula and then the other one, which I'll say is intended to mean, this is intended to mean that agent I thinks phi is possible. So that's the intended meaning of this new diamond-shaped operator. So just to reiterate what I said a moment ago, notice we can define phi implies psi as not phi or psi, and we can define phi is equivalent to psi as, I guess in two steps here, we could say, well, first it's phi implies psi and psi implies phi, and then we could further express that in terms of the negation and the or connective if we wanted to. Or we could try to do it in some more efficient way. So these are the basic connectives that make up epistemic logic. And in a way, there's not too much that's new here. It's just we need to deal with these new connectives, the ones that have to do with the knowledge of different agents. So here's a little bit of an extra explanation of these new connectives. Notice that we could express the diamond connective with agent I in terms of the box connective. That is, we can express the idea that agent I thinks that something is possible in terms of the idea that agent I knows something. Now, of course, this is a matter of whether you accept this definition or whether this is reasonable in a given situation. But notice that if I say diamond I of phi, remember that's supposed to represent that agent I thinks or believes phi is possible. Well, consider this formula, and this pattern should maybe look familiar to you. If you write not box I, not phi, well, what does that mean? That means it's not the case. Let's unravel this one piece at a time. It's not the case that box I, not phi. So in other words, it's not the case that agent I knows not phi. Well, think about it for a second. What does that mean? That means that agent I must at least admit the possibility that not phi could be false. But for not phi, or the negation of phi, to be false is exactly the same thing as saying that phi is true. So in other words, if we want to write this out in the more complicated form, we could say it's not the case that agent I knows phi is false. But rephrasing that, that just means the same thing that we have up here, that agent I at least admits maybe some kind of possible world where perhaps phi is true. And of course, that's how we're going to define this more precisely when we get into the semantics, or what do we mean about models for this language of epistemic logic. Okay, just to wrap up this brief lecture, let's do a few examples and then we'll do some more examples in a subsequent lecture. So suppose P, the propositional letter P, represents the statement it's raining. Let's just go through some examples here. So if I use the box connective, say with agent number 1 next to P, then that means that agent 1 knows it is raining. And perhaps we can also bring in some other agent. We could say that not box 2 phi, P, not phi rather, but P, that means that it's not the case that agent 2 knows that it's raining. Or in other words, agent 2 does not know it is raining. Now notice you can think of some situations that probably don't really make sense in any sort of possible model for this new language. For example, you could write a formula like box 1 P and box 1 not P. I guess I should have parentheses around the outside there, but it's easier to read maybe without those. So this would say that agent 1 knows it is raining, and agent 1 knows it is not raining. Now, of course, you could talk about, or you could discuss some way in which knowledge might be imperfect. Of course, someone might believe they know something that isn't true. We'll get into that a little bit more when we talk about the semantics of the situation that we're looking at. But this is a kind of thing that we probably won't want to permit, at least in the basic form of epistemic logic that we're looking at. On the other hand, notice you can write something that looks very similar that actually isn't necessarily problematic. Let me write this down. What if we write not box 2 P and not box 2 not P? So if I write this very carefully and sort of formally, this would say that agent 2 doesn't know it is raining, and agent 2 also doesn't know it is not raining. Now, there really isn't anything paradoxical about this, even if we assume that people only know things that are actually true, which is going to be one of our assumptions for epistemic logic. So, what this formula is saying really is just that agent 2 doesn't have any knowledge of the proposition P. Agent 2 doesn't know that P is true. Agent 2 also doesn't know that P is false. So there are different things that you can say here that make sense. In fact, just to show one last example before we wrap up this lecture, what if we say something like this? Let me just write this, and maybe we'll just say what it means. I can take the box subscript 2, that is agent 2 knowing something, and apply that to a statement about the knowledge state of agent 1. So I could write something like this. Box 1 P or box 1 not P. Now what does that mean? Let's do a sort of looser translation here. So box 1 P would mean that agent 1 knows that P is true. Box 1 not P means that agent 1 knows that P is false. So in other words, what this is saying inside the parentheses is that agent 1 knows about proposition P, or agent 1 knows whether it's raining or not. Now, putting box 2 outside tells us that agent 2 knows that agent 1 knows whether it's raining or not. And if you think about it, that is the kind of situation that comes up in the real world. I mean, if you perhaps are not in a situation where you can tell what's going on outside, but perhaps you know that a friend of yours has a good view out the window, you might say, well, hey, is it raining outside or not? So you don't know yet, but you know that some other agent in the situation has the knowledge that you're after. And of course, that might lead you to ask a question or to try to obtain that information. So this could tell us, or if we want to translate this, it would be agent 2 knows that agent 1 knows whether it is raining. Okay, we'll do some more translation examples in an upcoming lecture.